Okay, dear students, today we are going to see the oscillator. As the oscillator, we know it, without any input signal, we can able to generate the waveforms. So, just consider this is an oscillator without any input signal. It can able to generate waveforms. It may be sinusoidal or non-sinusoidal waveforms. How is it possible to be able to produce the waveforms without input signal? So first we have to get the circuit fully connected with the help of a power supply. So an amplifier, if you are providing an input signal, it can able to produce a large gain of the output signal with the circuits. So when the circuit is starting, the circuits involved in that circuit like resistors and active and passive components can able to produce some heat that is termed to be thermal noise. That is said to be a thermal noise. This thermal noise can able to get some voltage drop due to this dissipation of heat that can able to provide an input to the oscillator with the help of a feedback. We know about very well about feedback circuit. So this can able to generate some input to the oscillator. Depending upon this input of an oscillator, it can able to provide waveforms. So what type of waveforms, what type of outputs can be produced means three type of oscillations can be possible. What are the three types? First one is growing oscillation. So if you consider your output signal is oscillate like a sinusoidal waveform, but due to the less number of input, more number of heat can able to provide a larger signal. It is said to be a growing oscillation. And second, damping oscillation. If the resistance can able to provide only less number of output, so somewhat reduces and make even able to zero. This is called as a damping oscillations. And last one is sustained oscillation. Sustained means we have to provide the stability. So sustained oscillation means from the starting of the waveform till the end of the waveform, or even if it is continuous, it provides stability. So these types, there are three types of oscillations are available. So how we can be able to get this sustained oscillation means there is one scientist, that is a physics actually, is called as Heinrich Charge Park-Hussein. He lives in the year of 1881 to 1956. He developed a mathematical equation or mathematical derivation to have this sustained oscillations, because the oscillations can able to provide the output should be stable from the starting to the end. So if we take an example like a simple pendulum, those are studied in our physics in the school itself. What happens when we are starting our oscillation? It has to provide equal balance of left and right, isn't it? That is a simple pendulum experiment. Let's say we have to make the sustained oscillation means we have to get one equation that should be maintained till your output, right? So what is it called means the condition for oscillation can be derived. We know that if you connect a feedback amplifier, how can you able to provide the amplifier gain? AB is equal to voltage gain divided by 1 minus voltage gain into beta if you have connected a feedback amplifier, right? So from this equation, what happens? If your A into B, consider what is actually A? A is a open loop gain and beta is the feedback factor. So if you combine this also, you can able to say this is the open loop gain only. If this AB, just you can see that if it is both are equal or it's maintaining a value of 1, if A and beta maintains a value of 1, what happens to this equation? Just you know that, right? A and beta both are equal to 1. What happens? The voltage gain without feedback amplifier divided by 1 minus 1, that becomes 0, is it right? So anything divided by 0, that is nothing but infinity. Anything divided by 0, that becomes infinity. So what happens from this oscillation? You know that if the infinity means we can able to get the gain for more number of larger increase in time, right? So this is nothing but providing oscillation. At a certain condition, the amplifier become oscillator, act as an oscillator. So we have to maintain this infinity to produce the oscillations. Is it right? So oscillation means what happens? Infinity means they cannot be able to know whether to go increase or to decrease. So it will, the center in the output will be, amplifier output will be oscillates like this. Whether we have to go for increasing or decreasing. So this is said to be a sustained oscillation. Though the sustained oscillation has to be maintained means what we have to do? Just you can see that what we have to do, we have to produce a waveform means what will be the condition? The total phase shift of feedback amplifier, because it's nothing but being as a feedback amplifier, is it right? Actually, this oscillation condition depends on these two things, these two parameters. One is A, another one is beta. What is a beta? Feedback amplifier. So what is the feedback amplifier? It should be a negative feedback amplifier. Negative feedback amplifier means what I have to do here, whether you have to maintain the phase shift of 0 or 360 degree. Is it right? If you go for a full cycle, whether it should be 0 or it should be 2 pi. Is it right? 2 pi or 360 degree. If we maintain this only, we can able to get the full waveform. So the oscillation should be taken as a full cycle. So the total phase shift of the feedback should be equal to 0 or 360 degree. That is the first condition we have to take. And what is the next condition? We have to maintain both the factors to be 1. So then only it can be cancelled together, we can able to provide get the oscillations. Is it right? So these are the two conditions here. So likewise, the first condition, the magnitude of the open loop gain, you know that what is it factor? What is small loop? What represents small loop? That's the magnitude, right? That should be equal to 1. Then only the equation becomes infinity. First condition. And second condition, the total phase shift of feedback amplifier should be 0 degree or 360 degree. So this is the condition that have been derived from the Bark-Fusion. So it can be said to as Bark-Fusion conditions or Bark-Fusion criteria for maintaining sustained oscillation condition. So they can able to ask in both the ways. So sir, whether we can able to provide only sinusoidal waveforms, is it possible? Means no, we can able to generate also non-sinusoidal waveforms. So if you go for some examples, LC oscillator, RC oscillator, even though this has some classifications, further classifications, LC means Hartley oscillator, Colpitts oscillator, and for RC, R-shift, phase shift, and even crystal oscillators also can be able to generate sinusoidal waveforms. Then if you go for UJT or 555 circuits or even Smith trigger circuits can be able to generate non-sinusoidal waveforms like triangular, shadow, even square waves also, etc. The applications of oscillator, where it can be used. In moreover, firstly, they have been termed these circuits to use in applications like TV, radio, and all. Because there we need a tuned circuit. So we need oscillations. Because if there is oscillation, there will be two parameters you have to consider. That's the thing about the VDA characteristics. Is it right? What is V? Voltage. Another one is current. There should be a magnification there. Because if you are tuning for a particular frequency or some things, we need voltage magnification also, current magnification also. Because if you have an enlarged amount of magnification only, the particular frequency which you are transmitting from the longer range can be extracted. So that is said to be one of the applications. So we used in FM, radio, TV, televisions, and another one we are mainly using in like laboratories, what they are called as function generators. Is it right? You have been gone through some experiments there. Why we are using the function generator there? To provide the input of sinusoidal waveforms or even shadow is there, square is there, right? When you are changing the inputs, the number of waveforms can be generated from the FG and you are connecting to the circuit. Then only you can able to identify what is the exact frequency of output or bandwidth of the output is maintaining the ratio. So here from this topic I am going to teach you the first one, LC oscillator, for your clarification with the help of a role play. First we can see what is LC. L can be termed as, you know it is an inductive or inductor. Okay, and S is termed for a capacitor. Inductor. What is the purpose of inductor? Whether it is active or passive components, you know it, right? So inductor, what they will do, it is nothing but an inductive coil. We are having here inductive coil. So it is type of your electromagnetic field, stores energy in the type of electromagnetic field. Likewise, if a capacitor that consists of your parallel plate, it may be your normal circuit, normal current circuit, it may be ceramic material, whatever may be, right? So this parallel plate capacitor can be able to store energy in the form of electrostatic field. This you have studied in the basic school itself, how the capacitor and parallel plate can be able to store charges like the plate which have positive can be able to generate negative on the opposite. Likewise in the negative region you have the negative capacitance in the below plate and they can be able to provide the opposite polarity in the inside of your capacitor. This will not be known very well, right? So these two can be able to couple together, and this is also called as a, both of them if you are coupled together, then it is called as a tank circuit. Why it is called as a tank circuit? because both are going to store energy. Both are going to store energy. So if you go for even in your home you are using a water tank, what you will do? Both are going to store the same water, so we can able to call it as a tank. The same way, it also stores energy. It also stores energy. It may be a voltage or a charge water maybe, but both are going to store in a circuit that is said to be a tank circuit. This tank circuit used mainly in, I told you, the telecom, radio, televisions, and even home generator. So what type of output if you need depend on that this parameter values can be changed. So we are going to see the operation of this LC oscillator circuit with the role I told you. First of all, what is inductance, what is capacitance. Is it right? So now we are going to connect together with the help of your supply. Then you can see whatever happens, whether we can able to provide or generate the waveforms. Our aim is to generate. It is the one type of sinusoidal waveform. So generate sinusoidal waveform. Before going, I will have to tell another one thing. How the coil will be behaving when you are connecting a circuit, when you are providing a circuit? How the coil will be behaving? Say with the help of EMF, right? Electromagnetic field. It can able to store or it can able to transfer the charges through the electromagnetic field. Likewise, capacitor, by changing the polarity of the terminal, if you are having plus and minus, it has been charging here. If you are minus and plus, it becomes discharging. Whenever there is no supply or something, the capacitor starts to discharge if there is energy stored in there. So we have to make this as consideration first, then we can go for the role play. Okay, see, this is the role play. Our student is going to help for understanding this concept. So initially, I told you, a LC, that is the inductor and capacitor is connected. I was going to have it. So the student is going to play the role of inductor and capacitor, likewise switch and then DC power supply. So initially, when we are connected together capacitor inductor, it doesn't have here, the element doesn't have any source of energy. So it's actually there is no energy above. They can be connected together on the forced path. So let's consider they are still down now because there is no charging of the conductor. Now, with the help of DC power supply, a switch has been connected. I told you why the switch is connected. The switch started with the DC power supply. Now, the switch is also open one, so there will be no connection between the switch and the circuits like the tank circuit, that is inductor and capacitor. Right. Now, I am going to close the switch. I am going to close the switch. What happens now? The power supply is connected toward the capacitor with the help of switch. So now the switch is being closed here. The capacitor now starts going to charge. So they are going to start charge till it gets more energy. Okay. Now the capacitor has been charged here. Inductor is not full, not has been going to charge because all the energies has been getting from the capacitors. It has a parallel way. So they can be able to grasp all the charges to the capacitor. Now what happens? Now I need only the charging of storage and charge only the capacitor. Now the switch has been disconnected. Okay, so there is no input supply provided to the capacitor or inductor now. Okay, so I am going to remove the power supply as well as switch now because there is no working of hereafter. There is no need of working of your DC power supply and the connector, the capacitor. See here, now the capacitor having full energy. That's now capacitor is having full energy. But inductor doesn't have energy because they have the energy only they can able to act upon. So now what I am doing here, the capacitor is going to discharge this because there is no supply connected here. So what happens to capacitor? There is no closed path. There is only one closed path is inductor. Is it right? There is only one closed path is called inductor. So whatever happens, they have to discharge all the charges with the help of inductor only. So what happens in the mode 1 operation? This is going to mode 1 operation. What happens? The capacitor is going to discharge its charge carriers towards the inductor. So what happens? The inductor is going to charge now. Then it's going to charge now. Now capacitor is going to lose its energy. It's going to have the capacitors. So what happens here? What is the purpose of inductor? They have the charge. The minimum actually to say that when the capacitor and the inductor has an equal charge, what happens? There will be no transformation happen. When the inductor is having more charge than the capacitor, automatically the inductor produces this electromagnetic field. Produces electromagnetic field, right? It can be able to produce the EMF. Now the mode on operation, what happens? You can see the mode 1, capacitor is going to discharge. Okay, the mode of capacitor, what happens? From 0 to A, in the negative region, capacitor is going to discharge, right? So the electric can able to produce this electromagnetic field. Okay, when it's having its full energy, what happens now? The capacitor has been drawn, fully drawn the energy. Now capacitor is 0, inductor is having the maximum energy. Okay, so that maximum energy. Now what happens? Now the inductor has to have a closed path because the current should be flowing in a closed path. Is it right? So that to flow, there is only one place, that is called capacitor. But the inductor does not have the same polarity like capacitor. So what happens? They will provides the back EMF. So now the inductor can be able to change its polarity. Now the inductor can be able to change its polarity. Now so what happens? Now the charge from the inductor is going to discharge. There's nothing but charge stored in nothing but in the waveform of back EMF, the electromagnetic field. So the electromagnetic field will touch the capacitor now. The capacitor, what happens? From the electromagnetic field, they can be able to store the energy. Right? They can be able to store the energy now. So now the inductor is going to lose its energy slowly by the waveform of electromagnetic field. You can see that the EMF of electromagnetic field is spreading. Now this mode 2. Mode 2, what happens? The capacitor is now charged because of the back EMF provided by the inductor. Is it right? You can now see that the mode 2 capacitor is charging from A to B. Okay. Now the mode 1 capacitor is charging from 0 to A. Now the capacitor is discharging there. Now the capacitor is charging from A to B. So this is the second mode of operation. Right? Now what happens after the operation of mode 2? Now the inductor doesn't have the energy fully. All the energy of the electromagnetic field has been given, transported in the form of electromagnetic field. Because of that, the capacitor gets its energy as a static electricity and they can be able to charge it fully. I already told you, when the inductor having more energy than the capacitor, it can able to provide the EMF. But now what happens? When it is lesser than the capacitor, automatically the electromagnetic field will be reduced. The magnetic resonance will be reduced. Right? So what happens now? It's down its energy. The capacitor is fully charged now. Is it right? Now what happens? Again, from the capacitor stores energy. There is no other closed path circuit is there. What happens here now? Again, it has to make a discharge. The capacitor again will have to make a discharge. It is fully charged. So when it is discharged, it means the electromagnetic field, the inductor can change its polarity again because now it gets energy from the capacitor. The polarity will be plus and minus will be changing here. Now gets back to the energy and start the storing enough energy. So I told you, whenever there is a much greater storage capacity than the capacitor inductor, it produces the electromagnetic field. It starts again the electromagnetic field. The mode 3 will be operation. This is the operation of mode 3. What happens now? Capacitor is going to charge. Right? That is the mode 3 operation here now. Okay, again here. So from B to C, you can see from the inductor, the back EMF. So whenever they produce the back EMF, what happens? Polarity is changed from minus to plus. So the waveform, the oscillator, the output frequency will be now in the opposite region, positive region. Is it right? So now slowly the capacitor is going to charge because of inductor, can able to change its polarity and they start growing. Okay, polarity. Okay, so now it loses energy. Now we can understand mode 3 operation. Is it right? Capacitor is opposite charging in the opposite polarity because of this back EMF, inductor back EMF. Again, right? Now the repetition. What happens now? When the capacitor gets its full energy, now the inductor is flowing, right? So the capacitor is now in the condition of providing supply or charges to the inductor. The mode 3, the mode 4 will again start discharging from the C to D. Is it right? Let us take D. So again, the capacitor is going to discharge, the inductor is going to store energy in the instrument. So you can see that now I can able to pass this condition. I can able to pass this condition. You can see that what does the waveform look like? It's a sinusoidal, right? It is a sinusoidal waveform generation. So what happens here? You can able to get the pure sine form. Capacitor discharging, mode 1 operation 0 to A. Now the capacitor is going to charge with the help of back EMF, and third mode capacitor is going to charge in the positive manner. So in the opposite polarity because of this back EMF, and again it's going to discharge and again it starts to 0 or at least a degree. Now we can able to understand what is the LC oscillator. It can able to generate the sine wave for the waveform oscillations. But it is theoretical. If we go for practical, due to some resistance or another type of devices available in that, what we will do here, they will loop for the current. What happens like a straw? It draws some current whenever the waveform is changing, whenever the mode operation is changing. What happens? Due to that, like a straw, I am going to take the voltage in everything. Whatever is passing a current close to part. So for again and again waveform, what happens? It can able to generate more current. So the storing of energy of capacitor indicator becomes reducing. So it can able to create a damped oscillation. I told you at this certain instant it can reach even 0 also. So in practical this is happening here. So we have to make this as a undamped oscillations, that is a sinusoidal pure generation of waveform. We have to maintain the AB open loop gain should be equal to 1 and the total phase shift should be equal to 0. Then only we can able to achieve the exact oscillation. Now we can able to tell that without power supply, this oscillator can able to provide outputs. Is it right? Without any input supply. Starting of the only we need a power supply to charge the capacitor. If the capacitor fully charged, then it's like a clock. It can able to provide the clock signals, the input signals back and forth. So from this, we can able to get a sustained oscillation back and forth. We can able to. So just assume that if it is going on a rapid manner, what happened? The speed, you can say the 2x or 3x speed, what happens? You can able to generate oscillations like this. Capacitor charging, inductor discharging. Inductor charging, capacitor discharging. Opposite polarity. Again and again this is changing. So you can able to generate the sinusoidal waveforms. So I think you have been understood very well about the SC oscillator circuit. Okay. So thank you for listening. That's all.